Hi guys, welcome. Myself Venkatesh Gowda and I am from Sri Venkateshwara College of Engineering and I am from CSE branch. In today's video, we shall discuss about the applications of physics in computing and introduction to motion and timings in animation. So let's start the video. So first is the introduction part. Motion and timing in animation. Motion is an essential component in games and animations. The motion is governed by the Newton's law and kinematic equations. When animating a scene, there are several types of motion to consider. These are the most common types of motion. They are linear motion, parabolic motion, circular motion, and wave motion. Next is the motion line and paths. Motion as the path of action, which indicates the path along which the object or character moves. The path of action refers to the object's motion in space, while it can help show timing. Its primary function is to see the direction and path of motion and not necessarily its timing. We shall discuss about the timing in animation. The timing is the choice of when something should be done, the regulation of occurrence and pace to be achieved at desired effect. Animators have the ability to move forward and backward in the time to place objects and when they are to be. Timing tools. In animation, timing of action consists of placing objects or characters in particular locations at specific frames to give the illusion of motion. Animators work with very small intervals of time. Most motion sequences can be measured in seconds or fractions of seconds. Frame intervals between keys are usually smaller than 1 second. Now we shall discuss about the linear motion timing. Linear motion refers to the motion in a straight line, always in the same direction. An object moving with linear motion might speed up or slow down as it follows a linear path. A heavy ball rolling on a table or incline is an example of linear motion. The ball is rotating, but its center of gravity follows a linear path. A heavy ball rolling on a table or incline is an example of linear motion. The ball is rotating, but its center of gravity follows a linear path. We shall discuss about the uniform motion timing in animation. When uniform motion occurs, the net force on the object is zero. Net force is the total of all forces added up. There might be several forces acting on the object, but when both the magnitude and direction of the forces are added up, they add up to zero. Uniform motion is the easiest to animate because the distance the object travels between the frames is always the same. Uniform motion is a type of linear motion with constant speed and no acceleration or deceleration. Next is the constant force. So what is constant force? A constant force is a force that doesn't vary over time. Examples of constant force include gravity pulling an object to the ground because the gravity is always constant. Friction bringing an object to stop. Next is acceleration timing. Timing for acceleration can be calculated very accurately when the net force being exerted is constant. Now we shall discuss about the slowing and slow up in animation. When motion is accelerating or decelerating, we refer to this type of motion as slowing or slow out. This type of motion is sometimes called ease in or ease out. In this book, we use the hyphenated form slow in and slow out for easier understanding. First, slow in, which means ease in. The object is slowing down, often in preparation for stopping. Slow out, this ease out. The object is speeding up, often from a still position. The term slow out can be confusing. Since it essentially means speed up, one can think of slow out as the same as ease out, as in easing out of a still position and speeding up to full speed. For example, a ball rolling down an incline or dropping straight down is slowing out, as it grows from a still position or slow speed to a fast speed. A ball rolling up an incline is slowing in. Here we can see an example. A ball rolling down is an example for this type of animation. Next is the constant force and acceleration. Constant force results in constant acceleration. Because the acceleration is constant, we can figure out the timing for such sequences using a few principles of physics. The resulting acceleration depends on the direction of force and motion. If there is any motion to all begin with, first, When constant net force is applied to an unmoving object, the result is acceleration. Second, when constant net force is applied to a moving object in the same direction as the motion, the result is acceleration. Third, when constant net force is applied in the direction opposite the existing motion, the result is deceleration because acceleration in the opposite direction is called as deceleration. Thank you.